Namaste everyone. Welcome to the SWAYAM course of image processing using Python. My name is Dr. Atul, Assistant Professor from Bundelkhand Institute of Engineering and Technology, Jhansi. In this session, we will explore the world of basic image filtration techniques with the help of topics like noises in images, image filtering, mathematics behind image filtering, basic filters, and at last of the lecture, I will conclude the lecture and tell expected outcomes of the lecture. We all know that filters are very important in our life, and we all use filters for different purposes, for water filter and filters for different salt and different things. But in this case, filters are different. We are focusing on the filters for the images. So here the first of all I will introduce the noise to you, and noise filtering will be discussed. Basically, noise is unwanted result of data acquisition, and it comes from many forms and many sources. For scientific images, Microsoft, maybe the region MRI and other, there are many type of noises coming into the in account while taking videos and images. Because of the sensors also there are noises, and so there are many noise in the picture. In addition to salt and pepper noise may also show up from analog to digital conversion also. So we can say filters are very important in signal and image processing. This is the one of the very mostly used part of the image operation. In addition to the denoising, filters also do remove the blurs coming in the images. They also enhance the quality of images. Also they if you want to do some changes in the image, if you want some other things, then also you can use filters. So therefore if you want to get some desired result from the image, then also you can use filters. How do we do the filtering? If you have gone through the signal processing course, you must have learned convolution operation. And so this convolution is one of the operation which is part of which is having four kind of operators: addition, summation, shifting and integration. So this is the extended to the this convolution operation is nowadays very famous in the modern deep learning and machine learning AI techniques, that are convolutional neural networks. So they are very popular nowadays. From last few years these techniques are very popular in the market. So they are convolutional neural networks. So the basic principle behind these CNNs is convolution. The difference is that while above is a predefined filter having a fixed set of coefficients, however in convolutional neural networks the values inside the kernel of the filter, that means filter coefficients, are not fixed. They are based on the machine learning to find a specific feature or to accomplish the specific task. To apply the filter, for example, if I select a 3x3 filter, the 3x3 window slides over the image. The process of sliding a filter over an image is called convolution. In a spatial domain, the window will be placed on each pixel. Think of it. Think of this process. A cell over a matrix in an image where there is center, filter should overlap the pixel and go on. Once this overlapping completes, the pixels in the sub images that are the filters on the top will be multiplied by the corresponding coefficients of the filter. In this case, if I have a 3x3 window, the new values will be similar to the size of 3x3. Finally a center pixel value will be replaced by new value using the specific mathematical equation, that is the convolution equation. If you are all knowing this equation, depending on the filters used. So in order to carry out this process, either you can use convolution or a similar term to convolution, that is called correlation. The difference between convolution and correlation is that in convolution we have to take conjugate of the image or conjugate of the filter, but in correlation conjugate is not required. Only you have to overlap the image, move the image, take the summation and get the result. So you can see here the equation of correlation and convolution. You can see that in the equation of correlation there is plus sign. Plus sign indicates that we don't have to take the conjugate, we don't have to move it negatively, okay. And in convolution there is a negative sign, so there is f I minus u and j minus v, and the result is h cross f, means when we apply this to any image, then we have to take convolution. The result of this convolution will be the resultant of the filtering process. Okay, so you can load the dependencies, all the libraries, import numpy as np, so I will call np to the numpy, and pandas as pd, although I am not using pandas here, cv2 as cv, Google Colab patches. From sk image we import io for using the imread command. Sk image you import color, pil image, and matplotlib is important. So for matplotlib I will use plt. This is important. If you are using Google Colab, then you have to mount the Google Drive. So to mount this, you have to write in these commands, like from Google Colab import drive, then drive.mount content.drive. When you click on the run button of this code, you will see this is the run button, and you will see that it will ask for the permission to you. Then it will say that permit this notebook to access your Google Drive files. Because Google Colab, then you have to allow, you have to click on the allow, and after clicking on the allow, you can add noise to the image. Now we are starting working on this images. So for adding noise, you can use the predefined filters available on the OpenCV, but here I am writing custom function to add the noise. So you have to use this image filtering repository in you can go to my image filtering repository in GitHub. You can download all codes from there. Link to this repository in image filters is github.com dratul/image filters. We have to define the noise, then we have to take the pixels. So number of pixels you can take, and then read the image from the by using the imread command. And for plotting, here I am using subplot command. So you can see here I am taking the 1 and 2. IMShow to show the image, axis off, AX0 axis off. This is important. If you do not write this command, then your image will be having the numbers in x axis and y axis. Then I am writing AX0 dot set title. It is not get title, it is not so it is set title. AX0 set title original image. It will write the title of the image as original image. Then I am adding noise to it, add noise, and then add noise function will add the noise to the image. And then IMShow command will I am showing the image in grayscale. CMap equal to gray is given because I am using the color map grayscale, and axis off. And then after adding noise, the title is given as image with added noise. At the result, if you click on the run button, and after this you will get two images. One is original image, second one is image with added noise. So the right side image you can see here, that is the image with the noise added into it, because some pixels you will see that some are black and black pixels coming into the image, that is salt and pepper noise. Okay, so now we have to remove the noise. So what is the way? The way is use filters. So the basic filters in image processing, in this session I will discuss only basic filters. The first basic filter is averaging filter or mean filter, and second one is median, then Gaussian. So let us start with the first filter, that is mean filter. In the averaging filter, we use the average of the nearby pixels. This filter is also called smoothing filter. It removes the high frequency content from the image. It also used to blur the image. Therefore, it is called smoothing filter or blurring filter. Consider the following filtering array. We will call the mean filter coefficients, and for each pixel the filter coefficient is defined by the neighboring pixels considering when filtering, and how much weight of to the those filters are given. The equation for the averaging filter is f of xy 1 upon mn summation g of st. Here mn is the size of image, and this filter can be taken, if I take 3 by 3 filter, then 3 cross 3 all values can be given 1, and because the total values are 9, therefore we have to divide by 9, and this will this filter is also called smoothing filter, and this smoothens the local variations, because if variation is there, average value will come at the result. So all values are replaced by average value, therefore the variations will be removed. Very nice. Let us go to the Python code now. So kernel, to write the kernel, we use the numpy np.full 3 by 3 divided by 9 1 by 9, and then print the kernel. Then you will see that 0.11 is coming, that is the averaging. From the numpy, I am taking this float positional format, and from scipy ndimage and ndi, and then I am taking one convol command from ndi, that is for convolution of this, because we have for filtering we have to do convolution, and for convolution we have to call convol command. Convol command comes in the ndimage library of the Python. So I am calling ndi here, and then from the CNV is doing the convolution result, and from the CNV why I am doing CNV dot round 4, so that all the results will be rounded up to the 4 number of decimals only. There is nothing special about it. On print CNV will print the filter. You can see the values of the filter. See these values, that the values are coming, for the first one pixel the value is coming as 0.11. Why it is coming at 0.11? Because 1 is divided by 9. See the upper side matrix, that only the third row, third column 1 is available, and all other elements are 0. Therefore the value comes at 0.11. Now see the results, that left side image is before convolution, the square 1, and after convolution to the averaging filter, values has been changed, the colors are changed. See, you can see that there is variation in the color. So the middle one is brightest, that is white, and as long as we are moving, the color is reducing slowly. Now I will apply this filter to an image, real image. I will take one mask and of 3 by 3, and this is special convolution function written in detail, that as the convolution work. So shifting is there, multiplication is there, then addition is there, all the things are performed using Python, and this is the result of my own function that I have written. Before filtering there is no larger noise, you can see the number of black points in the image, and after filtering the number of black points has been reduced a lot. There is advancement also in this filtering, averaging filter, that instead of using the constant weight, we can use a adaptive weight or some changed weight, some new weight. It is a little advanced thing, so results also will be advanced. I am not discussing here the weighted average filter in detail. I am not applying to the Python, but in the upcoming session I will definitely cover it. Next one is median filter. Median filter is also used for smoothing. its basic idea is to replace each pixel by median of the neighboring pixel. You know the median, mean, median and mode, three statistical parameters. So median is similar to that. In averaging, the value is changed, but in median, the value is from the data only. So that is what the advantage of median is. The filter works wonderfully. It removes the spikes introduced by noise into the image, especially impulsive noise or salt and pepper noise. Another advantage of this filter is that it does not introduce new pixels, that what mean filter or averaging filter was doing. So we can reuse the pixel values from the window. Unlike the averaging filter, it removes noise without losing edge information. This is important because if I apply a filter, edges of the image should not be lost into. If in a filtering process edges are lost, then filters are not good filter. So the median filter is better than averaging because edges of the image are maintained. Here in this picture I am showing that how median maintain the edges of the picture. Let us write our function for median. So I am obtaining the rows and column of the image and then transversing the image, then calculating the median of the pixels and replacing the corner pixels by its median. So for this purpose we have to take two loops. So for one loop I am taking I as a counter. For another loop I am taking j as a counter. From 0 to m minus 1 I will go up to the m size image, m is the size of the image, number of rows, j will go up to n, n is the number of columns in the image. I am taking one temporary variable in which the median of the pixels will be stored and it will continue and at last the stamp is sorted for the median and at last we will get the median filter. So see the result. In this, the left side image is the noisy image that was given as input to the system, to the filter, and after filtering noise, a lot of part of the noise has been removed. OpenCV library offers, from the OpenCV library there is built-in median function. So we can use that also. We can directly use that as follows. This is the program where median filter is written. Next one is Gaussian filter. Gaussian function is very good function of the signal processing. Gaussian distribution is represent distribution for many natural processes. Therefore, this filter is very useful, although it is very slow. Why it is slow? Because there is a lot of computation into it. So this is also done by the same process. Convolution is required for every filter, not only Gaussian, but whatever filter may be, convolution will be required until unless the process is different. Sometimes convolution is also not there because a process is defined in the filter, but mostly convolution is required. So this is also done by convolution, but we have to take the input array with a Gaussian kind of coefficient and Gaussian distribution kind of coefficient, then summing them all to produce the output of array. You all will be knowing this function, this distribution. There are three kinds of distribution in mathematics: Gaussian distribution, normal distribution and random distribution. Gaussian distribution I am considering here. Most of the researchers have considered this for the purpose of designing filters. So just like you see in this picture, do you remember how do we write the one-dimensional Gaussian function? Pause this video for 30 seconds and think about it. What is this? What is the equation for this? What kind of picture of Gaussian comes in your mind? there was something exponential. Now if I extend this equation to two-dimensional system, then how will it look like? This equation will become in two dimensions. Here there will be this will be the function of x and y both. So g0 x and y is equal to, exponential term is there, and before exponential there was some coefficient, that is 1 upon 2 pi sigma square, sorry, e to the power exponential x minus mu whole square plus y minus mu square. But mu, if mu is, this mu is what? Standard deviation. So mu is mean and sigma is standard deviation. So x minus mu x is mu mean in the x direction, and mu y is mean in y direction. So Gaussian filters require Gaussian function, and Gaussian function is a very important function in the signal processing, and this function is a distribution of the natural things. Like for example, if you think about the marks of students, most of the students get marks in the similar range. So the peak of the student, the peak of the marks comes in a concentrated place, and very less student get the top marks, less student gets fail marks. So therefore the distribution of marks can be represented by the Gaussian function. So this type of natural things, natural distribution of the like temperature. So temperature is peak at one particular day at particular hour, like that. So the distributions have the peak value at one time, and then there are the distributions also. So this Gaussian distribution is natural and naturally available. Therefore Gaussian function is preferred to be used as a filter. And later on there are extensions also in this filtering, Gaussian filtering. Like for edge detection there is log of Gaussian, means LOG filter, Laplacian of Gaussian filter, that is the extension of this Gaussian filter. And also there is weighted Gaussian filter. The weighted Gaussian filter means the weights of the averaging filter are decided with the help of Gaussian function. So that kind of filters are also available, and people have done research and improvements in the Gaussian filter. Therefore let us go to the Python implementation of Gaussian function. To implement this Gaussian function or Gaussian filter in the Python, we can use the OpenCV library. There is inbuilt function. Also we can write the complete detailed function for this also by using this equation that I have discussed previously. We can write the detailed equation also, but here I am using the ready-made function available in the OpenCV library. So initially I have assigned this, taken this image IMG_n. This image is the noisy image which we want to use for removing the noise, and then from IMG I am using cv.cvt color, means converting this image to RGB, because this already image is not in RGB, then RGB to gray, because we are going to perform all the filtering process and all those things in the grayscale images. Grayscale images are preferred to use because they are having less number of pixels or less number of computations are required. Therefore we can see the effects easily. And then the img_gauss, this is the Gaussian blur, or we are applying the Gaussian noise. So this is CV is for the OpenCV library, and cv.Gaussian blur, it will call the Gaussian function. Then IMGO is our image, 5 by 5 is the size of the image, and then IMG_m, this then I'm color in CV.color, then I'm applying this, and then this color.rgb to gray IMGM, then we are applying this original and seeing the Gaussian filtered image. So this IM show all, this will show you all the images, original also and also the Gaussian filtered image. And here you can see the result. Initially this image, the image of the rose is having the noise in this, and after the Gaussian filtering, a lot of noise, lot of salt and pepper noise that was applied to it has been reduced. The result can be seen by you. You can see the results here, that there is a lot of difference in the image, that is, or the noisy image and the noise removed from it. Okay, so I have already told to you in the starting that you can refer my GitHub for accessing the codes related to this session. So you can go to github.com/Dr. Atul/image filters, and there you can see all the codes related to this session. Now we are near to the end of this tutorial, and in this was very important tutorial and important session. In this session, let us take a small recap of all whatever we have discussed in this session. We started with how to use Colab, Google Colab, how to give access to Google Colab to access the images from the Google Drive. After that, I discussed about the noise, how to introduce a calculated noise into the images. Then what are the image filters, what are the filters, how does filter works, what is convolution, what is the process of convolution. I had given one example of image, a small matrix taking a filter of 3x3 size, and then applications of filters in image denoising. I had taken one image and applied 3 basic filters of image denoising, starting from the mean or averaging filter, then median filter, then Gaussian filter. And the Gaussian filter is important. You just keep note it. If you have not noted the equation, you can go back to in this video and note that equation, because we are going to use it in the upcoming sessions. Okay, thank you all. Happy coding. Meet you in the next session.